All right, so good morning and good afternoon again. This is Marcus Weingartner with Intel Press Relations, and I'd like to welcome you to this webcast that we're doing today about accelerating wireless. And I have an expert here with me, Thomas Lindner from Intel Mobile Communications. He will be walking you through the foils. And just before we start, I wanted to point out to you that we will be doing a Q&A session to the end of this call. So if you have any questions that you would like to direct to Mr. Lindner, please either post them into the comments section of this video stream on YouTube, or you can alternatively email them to karawalker@intel.com. This is kara.walker@intel.com, as written at the bottom of this foil. So with that, I would like to hand it over to Thomas. And Thomas, you will be walking us through the Accelerating Wireless presentation today.
Okay, thank you, Marcus, and welcome everybody, wherever you are in the world. And yeah, let me introduce myself first. My name is Thomas Lindner. I'm based out of Munich with Intel since 2011 and responsible for the product planning for our multicom products, which includes the cellular modems as well as the wireless connectivity. I joined Intel in 2011 with the acquisition of Infineon Wireless, and been working in the industry basically since the last millennium. So that to my person, and now let's get started and discuss how Intel is accelerating wireless. Well, as you can imagine, we at Intel believe that everything that computes connects. And based on that, we are looking on the developments on the market. We see semiconductors becoming smaller and more powerful, following basically Moore's law. So this enables more and more devices and usages. And such devices are also converging. And the converging devices are getting more and more mobile. So another development that we see on the market is the growth of cloud-based services. So your information and data is basically available everywhere. Now, of course, you want to access this information and your data from everywhere. So you need a network that is able to transmit that. And these are the high-speed networks of today, namely LTE, but also 3G and the connectivity technologies like Wi-Fi. And those networks continuously enable more and more rich and richer applications and services. And finally, that leads, of course, to devices like smartphones and tablets that need to feature a wide array of connectivity options to enable such connectivity everywhere. And that is today, of course, mainly the cellular and wireless connectivity, 2G, 3G, and 4G, but also Wi-Fi, Bluetooth, and well, Intel, as it is set up today, is obviously not new to the wireless business. We are, in fact, playing in that market for well more than a decade, and we are well established both in the high end with multi-mode modem solutions that you find today in a multitude of smartphones and tablets, as well with entry-level single-chip products in ultra-low-cost phones and in the M2M market. On top of that, we are also providing a variety of innovative connectivity products such as Bluetooth, Wi-Fi, and GPS. Our track record is basically quite amazing. We have shipped more than 2 billion transceivers over the past 13 years. These transceivers, if you put them next to each other, would cover the distance from the West Coast to the East Coast in the US. In addition to that, we have also shipped more than 1 billion SoCs, consisting of baseband and RF functionality to the market, and our products are in more than 300 designs with our modem. The thing that we want to make clear now today is our multi-mode LTE solution with 2G, 3G, and 4G is now available. And as you can imagine, we will not stop here. We have a clear commitment to go forward. So we have gathered all critical competencies in our very capable R&D organization. So you see we have built up competencies here in the integration area, and we have talked about that on the slide before. We have significant now resources available to do communications in mobile platforms with RF and LTE. We have our own connectivity team providing our own connectivity products. But we are not stopping there. We are also taking care for testing, validation. We have built up with significant investments our own interoperability testing lab in Hillsborough, where we are now also able to self-certify our products based on the GCF requirements. And we have extensive labs globally and simulation work that we are doing to ensure that our products are meeting the latest standards. So all in all, we can say we are having a world-class global wireless R&D that enable us to provide the market with very attractive products. Now, looking here at the track record of continuous integration, this is, of course, one of our important strengths. We can see it here at the example of the development of our RF products. When you look back 13 years, we were looking at a GSM GPRS transceiver that supported 3 bands. Over the years, in the same form factor with much growing functionality, we have added a huge number of additional bands, but also radio access technologies with continuously reducing the chip count, with keeping the required area very low. So we are offering integration and enabling more features, more modes, more bands, and we continue to do so moving forward. Apart from the integration capabilities, there are, of course, other key items that help us to do our strong positioning, and that is what we call Intel's unique DNA. That starts, of course, with the leading process technology. We are in this area recognized, obviously, as the leading semiconductor manufacturer. We are leading in technology. We are following Moore's law here, and that is for sure a significant differentiation versus other players in the market. Also, we are building on a strong brand that is recognized as being one of the strongest and most famous brands in the world. We have, as you have seen before in our discussion, we have all the ingredients that make the systems, let it be a PC, let it be a smartphone, or let it be a tablet. So we have everything in-house, and we based on that can do a co-optimization of all these products to come up with the best possible system for the respective purpose. Now, another unique thing to Intel's architecture is that it is available across all devices, from high-end servers over PCs, notebooks, towards tablets and smartphones, and that we are also able with our architecture to support multiple operating systems such as Android and Windows and others more. Then on the slide before, we already talked about our world-class engineering teams, both in the area of the application processors as well as in the area of cellular and connectivity. Now, another important thing when talking about wireless is, of course, that this entering this industry and sustaining the position in the industry requires enormous investments, and Intel is willing and capable to do these investments and has a strong commitment to be a major player in this industry. So before we now dive into the Intel LTE solution, just a reminder that at the end of this presentation, we will have a short Q&A session. And if you have any questions, please use the comment field next to the slides, or send an email to karawalker@intel.com. So it's kara.walker@intel.com, and Kara is spelled with C like Caesar at the beginning. Well, what we see today is that the LTE market is just getting momentum and taking off. And we can see that in 2013, there were 166 million subscribers of LTE in the world. We expect that to grow until 2017 to more than 1 billion subscribers. So that is a huge increase until that time. And we think that we are now here at the right time to enter that market when it really starts to develop. Yeah, LTA is there now, and it addresses the requirements of what I described before as a world where everything that computes connects. And LTE supports this motion quite significantly. Benefits that we see, of course, is additional capacity to meet the growing data demand. So the content that is transmitted is basically growing on a quarter-to-quarter basis. The old existing radio access technologies like 2G and 3G cannot further cope with that demand. LTE provides quite some headroom by providing more spectrum in terms of frequency bands, as well as higher data rates over a given spectrum. So what we also see is we now have the high speed, and what is also very important, the low latency connectivity that we need for those applications that the users want to do today, like HD video and music, the video conferencing, for example. When we think of gaming, latency is very important. And of course, if you download something, you want to have it as fast as possible. What we also see is that with voice over LTE, there will be a native voice solution on LTE that will provide better voice quality over a more efficient transmit mechanism. And over time, this will enable LTE to be a standalone technology and make some of the more exotic legacy technologies obsolete. Of course, as every new technology, LTE comes with a number of challenges. First and foremost, what we see is the band fragmentation. There are more than 40 bands assigned worldwide right now. And of course, every country, every operator has its own particular combination of LTE bands. So when looking back in the world of 2G, we were talking about 4 bands. In 3G, it was 5. Now we are talking 40. So this is a significant challenge to a small form factor device. And we will see on the next slides how we cope with that. Another challenge, especially to the ecosystem, is currently the lack of competition in several areas of the value chain of the LTE ecosystem. Competition has not yet started, and the whole ecosystem is waiting for competitors to enter that market. Another important challenge is whenever you add a new radio access technology in addition to the existing technologies, you can expect that this will, at a first glance, lead to a cost increase. However, we all know that the highly competitive market where these products are going into and the end users are not really accepting such a cost increase. So every device manufacturer is faced with the challenge to cope and to handle this topic. Well, the same thing, adding additional functionality can impose the risk to have a higher power consumption on the device. Also here, the suppliers are required to find ways and solutions to mitigate that risk. And also here, we have taken quite significant measures moving forward to ensure power consumption that is completely in line with what we know from legacy products. A further challenge is the topic of coexistence. Coexistence in this context means that some of the bands that we referred to above are very close to other communication technologies like Wi-Fi or Bluetooth, and they have a tendency to interfere with each other. And also for a competitive LTE product, you have to manage that coexistence. And then the next big challenge that is coming to this ecosystem is to enable global roaming. We are prepared for that. However, there are still some steps to go in the ecosystem. Now, what is our ambition? We are, of course, focused on delivering highly competitive products. And in our announcement today with the 7160, where I show some details in the moment, we definitely have one of these products. What we are targeting at is we want to raise the bar in performance. So our first generation LTE product is already capable of supporting the full data rates that today's networks offer. So we can go here up to 150 megabit per second in the downlink. We also leveraging our traditional strengths in the area of power efficiency, where we always had a leading position and where we keep that with our new product. And also in the area of size, meaning the required PCB area to place the solution. Also here we think we have a significant advantage. Overall, we will also help the manufacturers to reduce cost. And of course, we will support them in their global operation across regions, technologies, and devices. So at the end of the day, what we want to do is we want to enable a smaller, more efficient and usable device. And here it is, our first LTE solution, the Intel XMM 7160. It comes with global mobility and the support of 15 bands in one design. Those 15 bands, according to our market intelligence, will enable a device that can operate on a global basis. So you will be able to cover all major markets with this selection of bands. This, as a consequence, would mean for manufacturers of devices that they can serve the global market with a single global SKU, or at least with a small number of different SKUs, being somewhere between 1 and 3. This, of course, reduces all the logistics and development effort, because the number of product variants is significantly reduced. The 15 bands, as mentioned before, gives pretty good global roaming capability. And it is also protecting the investments of the device manufacturers and giving them the future proof, as they can easily react to new band combinations on the markets that they address. With regard to power consumption, as I said before, we regard that as one of our major strengths, and some of the industry analysts have taken an analysis here, and we see 20 to 30% less power consumption than our leading competitors. And similarly, we think we offer here the smallest cellular solution, which is approximately 12% less than the solutions that we see today on the market. And of course, this is a product that is supposed to go into a broad range of devices, ranging from smartphones and tablets via modules into PCs, and then also into the M2M market. And we even have launched a commercial product with a customer premises equipment to connect the home to the internet. And what we are particularly proud of in that context is also the analysis from Signals Ahead from February, where we showed performance-wise quite some success versus 10 to 12 competitive solutions that were evaluated there. And the other very important thing that I want to say today, this is not only the announcement of a product on our side, but we are also very proud to announce that it is now available commercially in the Samsung Galaxy Tab 3. So you can buy an Intel LTE powered device in the shops now in Europe and in Asia. And it is also based on a complete Intel solution, also with an Intel Atom processor, the Clover Trail Plus. Samsung is providing that product in different configurations with our modems in a 3G configuration based on 6260, and in the LTE configuration using the 7160 platform. It's a 10-inch display, and it is supporting Android. As I said, you can buy it in the shops now. I ordered one myself. It's a very attractive product, and we are very proud to have that on the market now. So the bottom line here is that we think that the market now has a real challenger, and the ecosystem has a choice. Now, moving forward, going a little bit more into the details of the product, what you can see here is a high-level diagram of the configuration. The XMM7160 platform consists of two major parts. One of them being the Xcode 716G, that is a baseband chip supporting FDD LTE, HSPA Plus and Edge. It has in its package 1 gigabit LPDDR2 memory and its power management unit. This baseband connects to the application processor via USB HSIC interfaces or via MIPI HSI. The baseband is manufactured in a 40 nanometer process. The baseband then connects towards the RF through a digital RF interface. And the RF is our Intel Smart E4G chip, supporting the same radio access technologies as the baseband. It also has its own PMU in its package and is manufactured in 65 nanometer. The radio transceiver then connects to the RF front end. Now, as I said before, with 7160, we are not stopping here. We are moving forward to further improve products for LTE. And one of these further improvements is our SmartTY M4G. This is a transceiver module that includes the filters, duplexes, and switches of the front end, is provided in an LTTC package, and provides a number of advantages to our device manufacturers. First of all, it enables an easier design of the RF front end, as most of the components are already integrated into the module and are also fine-tuned with each other. So the only front-end components that remain outside are basically the power amplifiers. The SmartTY M4G enables a very small footprint. Yeah, so you will see a reduction in area of around 20% versus a discrete front-end solution. It enables very easy development, and at the end of the day, it is also designed to support lower cost PCB implementations. Now, moving forward, we also announced today a set of new PCIe M.2 LTE modules that are likewise based on our XMM 7160 platform. We are providing these modules in cooperation with our partners Sierra Wireless, Huawei, and Telit. And the M.2 module is basically a small, cost-effective form factor that you can integrate into PC, ultrabooks, tablets, and other connected devices. It also features our own Intel GNSS, the Global Navigation Satellite System solution, that is based on our CG1960 GNSS chip. Of course, it has all the functionality that the 7160 platform can offer on multimode cellular. And this module is already adopted by leading PC OEMs for their 2014 product lineup. And while we have already achieved the GCF certification for that module, we are now in the phase of doing the interoperability testing with the leading global network operators. All right, and as I said, even there, we are not stopping. We are moving forward, and we are at this stage also very proud to let you know that the 7160 that we just discussed is coming with some quite enhanced features. One I mentioned before, that is the support of Category 4 or the 150 megabit downlink, but it is also fully developed to support voice over LTE, also with the advanced feature of single radio voice call continuity. So we have here a full-blown multi-solution that can enter the market today. Of course, here further steps need to be aligned with the overall ecosystem readiness, but this platform is already prepared for that. Now, in half a year from now, in the first half of 2014, we are going to launch our second generation product, the 7260. Here we will add additional functionality, meaning carrier aggregation, so that we can combine bands for higher bandwidth and data rates. We will, with that product, also support TD LTE as well as TD-SCDMA. So to make it then a product that can also cover the worldwide TD operator landscape. We will improve here also to faster network speeds. We will introduce a next generation RF transceiver that will help us to improve all the critical performance indicators that we discussed. And of course, it builds upon the achievements of our first generation 7160 product. Now, what you see on the bottom of this slide is our 3G lineup. We have there our famous 6260 platform that we shipped a couple of 100 million times to the market. We have the 6360 that supports 42 megabit. And then we have also, as a next step on 3G, our 6255 platform with the world's first power amplifier integration into an RF chip. But first and foremost, I would point you to the 7260. We have demonstrated the functionality already in the Intel Developer Forum a month ago in the US. So also that is a real product, and we will see initial products based on that in the first half of 2014 with carrier aggregation, with TD-LTE, and with TD-SCDMA. So that concludes my presentation on the background of what we have announced today. Summing it all up, we are now there on the market with our XMM 7160. It is available in a leading tier 1 product in the Samsung Galaxy Tab 3. We are accompanying it with a number of module solutions to enable additional device manufacturers to adopt our solution for special purposes. With the M.2, we have a very good means to enable people that don't want to invest themselves into wireless R&D to adopt the technology quickly and cost-effective into their products. And with the Smarty M4G, we have a special RF LTE solution that enables, again, cost savings in R&D, less risk, as well as a very, very attractive footprint and/or low-cost PCB implementations. So, having said that, I think we can turn now to a number of the questions that have been asked.
All right, thank you very much, Thomas. So as people watching the webcast may have seen, we did get a couple of questions in the comments, and then also Kara has a few. I will get you started, Thomas, with the first question, and then we will have further questions read out by our colleague Joanna here in the room. So basically, the first question is, can you talk about the importance of 64-bit in that space, and also tie that together with the aspect of power reduction?
Okay. Well, I think here, as I'm not the major expert on the AP side, and my area of expertise is more the modem here. I think it would be good if you have a look at the technology at Intel Block, and I think there is a post by the chief architect of our Atom processors on this topic, where you can get further information on your question.
All right. Thank you very much, Thomas. Joanna, would you be able to read out the second question, please?
Yes. Our second question comes from someone who works in IDC, and the question is, can you provide a view on a state of maturity and stabilization of VoLTE, and perhaps some indication of when we will see broad deployment?
Okay, so I think here the answer is as follows. The VoLTE is a standardized feature. We are developing against this standardization, but VoLTE is also a feature that requires an end-to-end tuning of the entire network from the one device to really the other end, the other speaker. And this we are doing in cooperation with the operators. Today, as we speak, I think there is only one real VoLTE deployment commercially in the world, that is in Korea. All other networks are still testing, and I would expect a real deployment of VoLTE somewhere in the first half of 2014. And as I pointed out before, our solution is prepared for launch in that time frame. The development towards such product launch will obviously be done in very close cooperation with the respective operators.
And our next question comes from our viewer Neil Shaw, who could first of all congratulate you on the move to multi-brand LTE solution, and asks if you can provide more color on TD-LTE or TD-SCDMA support. Okay, so I think I pointed that out on the last slide. We will introduce both TD-LTE as well as TD-SCDMA with our 7260 product. Both of these technologies will be fully integrated in both the baseband and the RF. So they are not coming with any additional device, but they are fully absorbed in the main chipset. We also provide them based on the same definitions like the FDD, so same data speeds on TD-LTE as on FD-LTE, with the exceptions that from the standard, the TD-LTE data rates are always slightly lower than the FD-LTE data rates, but we are supporting the same class. TD-SCDMA we fully support to the China mobile requirements, which is, let's say, the only bigger operator that is entertaining the standard. So here we are fully compliant. And Neil Shaw also asks the following question. As Intel is actively working with Asian vendors, for example, India and China, on SoCs in those geographies, how are the synergies with Intel SoCs?
Okay, so in general, I do not want to comment today on any specific relationship with any vendor, regardless where he is on the world. I would like to say that, of course, the Indian and China markets are very important markets for us, and we are, of course, having a big focus when defining our products to comply with the specific requirements of those geographies.
And our next question comes from Leo Yim, and asks, will you be sharing some information about the plans on the next gen, for example, the Intel XMM 7260 with LTE advanced TD-LTE, TD-SCDMA today?
Yeah, so I think I did that. I showed the 7260. It will be available in the first half of 2014. As I said, it supports TD-LTE and TD-SCDMA. It also supports the LTE advanced features. The most prominent of those, obviously, is carrier aggregation. But there's also a bunch of other LTE advanced features that, of course, make it an LTE advanced device, and we are supporting all of them.
Our next question comes from Electronicality and asks, when will Intel have an integrated Atom plus LTE modem solution available?
So here I can say we are continuously working on integration, and I showed you that integration is one of our key strengths, and we develop that further and further. But today, as we speak, I do not want to do an announcement on any such product.
And Ashraf Ayasa has two questions for you today. The first one being, when you say first half of 2014, do you mean in products and on shelves, or beginning to ship to OEMs for the second half of 2014 availability?
In products.
And his second question is, also with these modems built on TSMC's process, does this imply that Intel is still very far off from an integrated SoC and apps processor solution?
Yeah, as I said, today I have nothing to announce with regards to the integration. However, I can also not really follow the conclusion. So let's postpone that to one of our future announcements.
And lastly, by Kudur Sulman, he asks, is there any time frame for SDR technology?
Well, I take it that SDR is referring to software-defined radio. And I think from my personal perspective, SDR technology as such is not a value on its own. We have integrated some ideas from an SDR philosophy in our products where we thought it is suitable, but at the moment I don't think that SDR is a major trend that the industry is following.
All right. Thank you very much, Thomas. This concludes our call for today. So these were all the questions we got. So please, if you should have any further questions at this point, or following up by listening, viewing this webcast, please get in touch with your PR manager, be it in Intel Americas or in Europe, Middle East, Africa, or Asia. Please get in touch with those PR managers, and they can definitely help you to answer any questions you might still have at this point. Thank you very much for listening, everybody, today. And I just hear we are getting another question. Joanna, can you?
Yes, sorry.
All right.
We have more questions here. We have another question by Ashraf Easa, and he asks, finally, how important is an integrated apps processor and apps processor solution in the broader markets? For example, will the XMM 7260 be relegated to high-end, or can it be more broadly adopted?
So I think the 7160 and 7260 are surely targeting the higher end of the market, but they will not be limited to the very high end, as they are very cost-effective solutions. So I think it's probably better to describe them to be able to cover the upper half of the market.
And we have here Maribel Lopez, who asks, have carriers asked Intel for anything special to support LTE?
Well, here I can say at a high level, yes, they are of course asking for specialities depending on their own plans, and we are cooperating with all the leading network carriers, and we have included those requests into our products, but I cannot at this stage disclose any specific request that they had.
And Tom De Beer would like to first of all congratulate with the move to development of LTE chips. He thinks that's very smart at the moment. And he has a little question. Will the new LTE chips be used in notebooks as well?
Yes, definitely. The M.2 product that I have shown on the slide is mainly targeting notebooks and ultrabooks. And through our partners, Huawei, Sierra Wireless, and Telit, we already have engagements with leading PC OEMs for their 2014 product lineup.
And as our last question, it comes from ABI. What is the expectation for when M2 interface will be commonly implemented like the PCIe mini card interface has been historically?
Yeah, so I think here you can say from latest 2014 onwards, the M.2 will be in that state.
All right. Well then, thank you very much once again, Thomas, for answering these additional questions. And I will repeat, if you have any further questions, please contact your PR managers, Kara Walker directly, or your local PR people, wherever you're located at. Thank you very much for watching this broadcast today, and have a great day.